I have already discussed with you first 4 properties. Now the property 5 and 6, which are very important. Look at property 5. Please note down. If some or more elements of a row or column of a determinant are expressed as sum of 2 or more terms, then the determinant can be expressed as sum of 2 or more determinants. What do you mean by this? Let us take an example. Suppose you are given a determinant, say the elements of the first column are A1 plus alpha, B1 plus beta, C1 plus gamma. And the other 2 columns are A2, B2, C2 and A3, B3, C3. So the property says, what do you find here? That the elements of the first column are expressed as sum of 2 numbers. So the given determinant may be, rewritten as sum of 2 determinants. One will be A1, B1, C1. The rest of the 2 columns will remain the same, A2, B2, A2, B2, C2 and A3, B3, C3. And plus what will be the other determinant, the second determinant? In that the elements of the first column will be instead alpha, beta, gamma, and of course rest 2, A2, B2, C2 and A3, B3, C3. That is, the elements of the second and third row will remain the same. That means the given determinant delta may be expressed as sum of 2 determinants, say delta 1 and delta 2. Now the next property, property 6, which is the most applicable property. Just note down, if to each of any 2, please note it again, if to each element of any row or column of a determinant, the equi-multiples of corresponding elements of other row or column are added, then the value of determinant remains unchanged. By this you mean that if you take ith row and then to this ith row you add to each element k times the corresponding elements of jth row, the value of determinant will remain the same. Or it could be column. If jth column, to each element of jth column, you add k times the elements of, say, if each element of, to ith elements, if you add k times the elements of jth column, the value of determinant will remain the same. For example, given is a determinant A1, A2, A3, B1, B2, B3, C1, C2, C3. And you operate it like this, that is R1 is to be replaced by R1 plus K times R3. What will be the new determinant delta 1? It will be, R1, that is A1 plus K times A1 plus K times C1. Similarly, A2 plus K times C2 and A3 plus K times C3. And rest 2 rows, that is B1, B2, B3 and C1, C2, C3 will remain the same. Then this newly obtained determinant will be same as delta. In other words, for proving certain results, if we have to add the elements of any one row or column to the corresponding multiple angles of any other row or column, the value remains the same. So this is the last property, and now I may take just one simple example before I shift to the exercise. Please note a simple example. Let's take an example. The instruction is without expanding. That means using at least 2 or more properties. Without expanding, prove that. In all such kind of sums, we have not to expand right in the beginning. First you take at least one or two application of properties and then sometimes toward the end you may expand. But here he says just don't expand it at all. Without expanding, prove that the value of this determinant, say I may denote it by delta, x plus y, y plus z, z plus x are the elements of the first row, that of the second are z, x, y, and third row are 1, 1, 1. Prove it equal to 0. So let's see how to prove it. Now, the first property here I apply, that replace the elements of R1 as R1 plus R2. But before you start writing, you have to think it orally. You know, there is no set rule to prove such kind of question. All kind of, logics you have to apply orally before you start doing. Why I have already written here applying R1 plus R2. You know that if you add say x plus y to z, you will get x plus y plus z. Similarly, in the second element you get x plus y plus z, and the third element of the first row you get, and then all the three being x plus y plus z I can take common to leave 1, 1, 1 in the first row, and you also have 1, 1, 1 in the third row. The two elements two rows R1 and R3 will become identical, and we can immediately conclude hence the value determinant is 0. So I have a thought of it beforehand. So R1 plus R2, what do you get? And of course it continues delta equal to y, because if to any one row, say R1, you add the elements of R2 or R corresponding elements of R2, it does not matter. So, and what do you get? X plus y plus z, z plus y plus z plus x, and z plus x plus y. All the three are x plus y plus z actually, keeping the other two rows the same, z, x, y, 1, 1, 1. And now taking x plus y plus z common from x plus y plus z common from all the elements of R1. So you get x plus y plus z outside a multiple, elements of first row reduced to 1, 1, 1. The elements of second row will remain the same, z, x, y, in the third row. Just by applying this property and taking common, what do you find? That here R1 equal to R3 or R1 and R3 are identical, and hence the value of the determinant will be 0. So your determinant will become x plus y plus z into 0 or 0, and that's what we have to